Alkenes. Introduction to alkenes. Alkenes are unsaturated hydrocarbons. General formula is CnH2n. Alkenes contain a carbon-carbon double bond somewhere in the structure. Arrangement of bonds around the double bond is trigonal planar and has bond angle 120 degrees. C double bond C is covalent bond, which has 1 sigma and 1 pi bond. Pi bonds are shown and have high electron density, so can be attached by species which are called electrophiles. Stereoisomers talked about in Introduction to Alkenes. Electrophilic addition reaction of alkenes. Double bonds in alkene are highly electron dense, so can attract electrophiles, and alkenes do addition reactions. Electrophiles are electron pair acceptors. Addition means produce one molecule from a reaction. Bromine with alkene electrophilic addition. Bromine used at room temperature. Electrophilic addition. Bromine molecule approaches the alkene's pi bond electrons, which repel the electrons in the bromine bond. This induces a dipole in bromine, making it polar, so one bromine atom is partially positive compared to the other. Electrophile is the partially positive one, which is closer to the double bond. Intermediate, which has a positive charge on the carbon, is called a carbocation. Hydrogen bromide with alkene electrophilic addition. Use HCl and HBr at room temperature by electrophilic addition, and in this case the electrophile ions the partially positive H. HBr is polar, because the Br is more electronegative than the H, making the H partially positive, so it is attracted to the electron-rich pi bond. Because it's unsymmetrical, two different alkenes can form. Markovnikov rule is when bromine is added to atom with a carbon with the least number of hydrogens attached to it. Alkene is unsymmetrical, so adding hydrogen bromide forms two isometric products. Electrophilic addition to alkene means major product is formed by more stable carbocation intermediate. Carbocation's intermediate is more stable because methyl groups on either side of positive carbon are electron releasing and reduce the charge on the ion, which stabilizes it. Order of stability from most to least stable is tertiary, then secondary, then primary. Exam tips: draw both carbocation and say which one it is, so primary, secondary, or tertiary. Say which one's more stable. Then say more stable carbocation is stabilized as methyl group on side of positive carbon are electron releasing and reduce charge on ions. If they're the same type of carbocation, then say there's a 50% chance of forming either. Sulfuric acid with alkenes electrophilic addition. First, use concentrated sulfuric acid at room temperature to do an electrophilic substitution, and the sulfuric acid will be the electrophile. Then add warm water for hydrolysis reaction. So sulfuric acid is basically a catalyst as it's reformed in the end. For unsymmetrical alkene, a minor and major product is formed and explained in the same way. Hydrolysis is when the molecule is split by adding water. Hydration of alkenes to form alcohols. Reaction called hydration as water is added to a molecule. Alkenes to alcohols normally happens in one step, not like the electrophilic addition reaction that happened before. Reacted with water when they're with an acid catalyst. For this, you need high temperature pressure and phosphoric acid as a catalyst. Using these conditions turns ethene and water to ethanol. High pressure means it can't happen in a normal lab, so done in industry. And because there's no waste products and it has a high atom economy, it means that it's easy to separate the product. Test for alkenes. Bromine water decolorizes when there's a double bond. Used as test for presence of double bond in molecule. Used quantitatively to show presence of multiple double bonds in a compound like polysaturated oils. Addition polymers. Addition polymers formed from alkenes, and this is called addition polymerization. Polyalkenes like alkanes are unreactive because of the strong CC bond and CH bond, and is written as equation to show number of repeating units. Repeating units don't need the N. Polychloroethene is polymer that's waterproof and is used as an electrical insulator that doesn't react with acid. Purely, it's a rigid plastic because of strong intermolecular bonding between polymer chains, which stops them moving over each other. Unplasticized to make PVC window from covering. Plasticizers added means intermolecular forces weaken, which allows the chains to move more easily, so more flexible in polymer. PVC is used to make insulation on electrical wire and waterproof clothing.